This is the deep space habitat. This is meant to mock up simulated missions out into deep space beyond lunar orbit. So if we're going to a near-Earth asteroid, if we're going to Mars, anything where missions that go beyond 6 months.
The deep space habitat should protect the crew from 250-degree temperature swings, not to mention a noxious atmosphere of deadly carbon dioxide. It has to. The nearest help is 34 million miles away.
One of the big issues we're dealing with is time delay. If we're at Mars, we may be 20 light minutes away from Earth. So if you just hit send on your text message, they don't get it for 20 minutes, and they don't answer you for another 40 minutes. We're used to having real-time control on board things like the International Space Station, where they have real-time video, they have real-time audio. How do those things work when you're in deep space? This is where we work that out, is right here at Johnson Space Center.
The 7 landers and rovers already on Mars are marvels of exploration. Their images and data have inspired breakthrough science and wide-eyed wonder. But the story of Mars is still locked in the rocks. Its history, its potential for life. We are literally digging for answers. And digging with robotic proxies isn't easy. A human picking up a rock and analyzing it with a geologist's eye would be far more efficient.
Of course, if we're going to go exploring, where a big part of that is the science. Physical science is here, what we call the GeoLab workstation.
The workstation has 3 vacuum-sealed ports where collected rocks can pass through.
What we're trying to figure out is which rocks are worth bringing back to Earth. Things cost on the order of about $100,000 a kilogram to transport to and from space. And so we can't, of course, bring back a ton of rocks. Here we've got an operating table that we can pull out. We've got ultrasound, which seems to be one of our best diagnostic tools on orbit. Look inside a person's body without having to cut them open. We can find tumors. And again, that information goes back to the Earth, where we have surgeons who would look at this information and use that to make diagnoses.
Everything the astronauts may need must fit into the 10-foot-tall habitat. They plan for every contingency.
If something breaks in space, you can't go to your local hardware store and replace it. Do you really want to take along 100 spares of everything? Because you don't want to take down 1 more ounce of material than you need. By the same token, you don't want to take 1 ounce less than you need, because that might cause your mission to fail. So you've got a very narrow sweet spot.